Good morning, students. Today we are going to discuss the numericals of uh, exercise 8C. That is the last part of current. Exercise 8C. So in this chapter, we have to deal with the formulas. First, I am going to write the formulas that P equals to VI, that is voltage into current. Then P equals to I square R P equals to I square R, that is the current squared into resistance. Then P equals to V P equals to P equals to VI. So if I substitute P equals to VI, now if I substitute I equals to V by R, then it will be V square by R. It will be V square by R Next, W equals to, that is energy, electrical energy, that is equal to power into time. Power into time, that is W equal to P equals to VI into T. Okay, VIT, it's the first form. Then W equals to, if I substitute V equals to IR, then this will be I square RT. We have to select the formulas according to the given informations in the question. Then W equals to, if I substitute I equals to V by R, then it's going to be V square T by R. V square T by R. V square T by R. So let's start with the formula. Start with the numericals. Question number 2. A current of 2 ampere is passed through a coil of resistance 75 ohm for 2 minutes. So I equals to 2 ampere. I equals to 2 ampere. Then resistance 75 ohm. R equals to 75 ohm. Resistance 75 ohm. Then time equals to 2 minutes. So time equals to 2 minutes, that is we have to convert this in second, that is 120 second. Okay, so I given, R given, T given. How much heat energy is produced? So it's very simple. We have to find out how much heat energy, that is W equals to I square RT, because I given, R given, T given. So I can write the formula here. I square RT. So I square, here I will substitute 2 square into R is equal to 75. Everything is given in SI, and time is equal to 120. Okay, next. So the answer will be 36,000 joule. Next, B. How much charge is passed? you know that Q equals to IT, that is charge Q equals to IT. So here you can substitute I equals to 2 ampere and time equals to 120 second, that is equal to 240 coulomb. Next, question number 4. An electric bulb is rated 100 watt 250 volt. How much current will the bulb draw if connected to a 250 volt supply? So it's very simple. Power rating and voltage rating given. P equals to 100 watt. P equals to 100 watt and V equals to V equals to 250 volt. P equals to 100 watt and V equals to 250 volt. So we can find out by using this formula. P equal to VI. So P equals to VI. So you have to find out the current drawn, how much current will be drawn. So I equals to P by V, that is equal to 100 by 250. Okay, answer will be in ampere. 100 by 250 ampere. It is 0.4 ampere. Next, question number 5. An electric bulb is rated 220 volt 100 watt. What is its resistance? So again we have to write power rating given 100 watt, then voltage given 220 volt. So you have to find out resistance. So you have to use this formula. P equals to V square by R. So R is equal to V square by P. That is equal to 220 into 220 divided by P equals to 100. So 0 will be cancelled. It will be 484. Okay, so answer will be 484 ohm. Next part of this question, what safe current can be passed through it? You know P equals to VI. So by using this formula you can find out. So this is question part A. Now part B. Part B, by using the formula P equals to VI. Okay, you have to find out the safe current, that is I equals to P by V. That is P equals to 100 and V equals to 220. Substitute properly. 100 by 220, it's 0.45 ampere. That means the maximum current that can be drawn, safe current. Question number 6. A bulb of power 40 watt is used for 12.5 hours each day for 30 days. So 12.5 hours each day for 30 days. calculate the electrical energy consumed. So we will find out by using this formula. See, power given. First write down power given, P equals to 40 watt. P equals to 40 watt. Then 12.5 hour each day for 30 days. So how many hours first calculate? That is time equal to 12.5 into 30. 12.5 into 30, so it will be 375 hour. 375 hour, that is the total time. Okay, calculate the electrical energy consumed. So we know that there is a unit called kilowatt hour. You know, kilowatt hour is not the unit of power, it's the unit of energy, because kilowatt is the unit of power and hour is the unit of time. So kilowatt into hour, this is the unit of energy. So I can write here W equals to P into T. W equals to P into T. Now the 40 watt, I have to convert this in kilowatt. So 40 by 1000 into 375. So my answer will be 15 kilowatt hour. Next, question number 7. An electric press is rated 750 watt to 30 volt. Calculate the electrical energy consumed by the press in 16 hours. So this electric press, the power given 750 watt and voltage given 230 volt. Voltage given 230 volt. Calculate the electrical energy consumed by the press in 16 hours. So here also you can use the kilowatt hour concept. So at a time, write down the time. Time is equal to 16 hours. So here we can write W is equal to P into T. That is equal to 750 by 1000. So convert this in kilowatt into time is 16 hour. So my answer will be 12 kilowatt hour. So my answer will be 12 kilowatt hour. Next, question number 8. An electrical appliance having a resistance of 200 ohm is operated at 200 volt. Calculate the energy consumed by the appliance in 5 minutes. So they have given you the resistance, that is 200 ohm. Next, they have given the voltage given V equal to 200 volt. Voltage given, resistance given, time given, energy consumed by the appliance in 5 minutes. So T is equal to 5 minutes, that is 5 into 60, 300 second. So you have to find out energy consumed. So your formula will be this one. See, V square T by R, because V given, T given, R given. So here write down V square T by R. So V square 200 into 200 V square into T is equal to 300 V square T by R is equal to 200. So 200 will be cancelled. 200 into 300, that is 6, then 6 into 10 raised to the power 4. 6 into 10 raised to the power 4 joule. Okay, next. Achha, this is the energy in joule, and they have also asked the energy in kilowatt hour. So what is the relation between joule and kilowatt hour? 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. Okay, so my energy in kilowatt hour will be energy in kilowatt hour will be 6 into 10 raised to the power 4 by 3.6 into 10 raised to the power 6. The answer will be 0.0167 0.0167 kilowatt hour. Next, question number 9. A bulb rated 12 volt 24 watt operates on a 12 volt battery for 20 minutes. Calculate the current flowing through it and the energy consumed. So current flowing through it, you have to use this formula. So write down P equals to 24 watt, P equals to 24 watt, and V equals to 12 volt, V equals to 12 volt, P equals to 24 watt. So current drawn will be I is equal to P by V, that is 24 by 12, that is equal to 2 ampere current drawn. Okay, the battery is used for 20 minutes, so it's the time is also given, T equal to 20 minutes, that is equal to 20 into 60, 1200 second. Okay, so you have to find out the energy consumed. So W is equal to, you can use the formula V square T by R. Okay, R is not given. VIT, use the formula VIT, because you know V, you know I, you know T. So you can use this formula VIT, because R is not given here, so no need to calculate R. If R is asked, then you can. So V equals to 12, then I equals to 2, then T equals to 1200. So answer will be 12 into 2 into 1200. Answer will be 28,800 joule. You can also find out the energy by using any other formula, but then you have to calculate the resistance also. Next, question number 10. A current of 0.2 ampere flows through a wire whose ends are at a potential difference of 15 volt. Calculate the resistance of the wire and the heat energy produced in 1 minute. So current given, potential difference given. That means I given, V given. So you can calculate the resistance by using Ohm's law. So write down I is equal to 0.2 ampere. Next, V equals to 15 volt. V equals to 15 volt. So resistance will be R is equal to V by I, because V equals to IR. So R is equal to V by I. V by I, that is equal to 15 by 0.2. So it's 15 by 0.2. Answer will be 75 ohm. Next, heat energy produced in 1 minute. So heat energy produced in 1 minute that is equal to, you can use the formula H equal to I square RT, because I given, R given, T given. So you can easily use the formula. Okay, so it is H equal to I square RT. So I equals to 0.2 into 0.2. R is equal to 75 into T is equal to 60. That is equal to 0.2 into 0.2 into 75 into 60. So it's 180 joule. Okay. Next, question number 11. What is the resistance under normal working conditions if an electric lamp rated 240 volt 60 watt? So you have to find out the resistance. P given, V given, same thing. So P is equal to 60 watt. P is equal to 60 watt, comma, V is equal to 240 volt. So you can find out R. So P equals to V square by R. R is equal to V square by P. So R is equal to V square R is equal to V square by P. So V square equal to 240 into 240 by P equals to 60. So my answer will be 960. Okay, 960 watt. Sorry, 960 ohm resistance. 960 ohm. Acha. So if two such lamps are connected in series across a 240 volt main supply, explain why each one appears less bright. So in this case you have to draw a circuit. These two bulbs, so this is a bulb and this is another bulb. So this one 240 volt 60 watt, that means it is 960 ohm. Bulb 1 and this is bulb 2. So bulb 1 960 ohm, bulb 2 another bulb 960 ohm. So these two bulbs, they are connected across this 240 volt. So definitely equivalent resistance, but total resistance of the circuit will increase. So what will be the equivalent resistance? It will be 960, because the two bulbs are connected in series. So 960 plus 960, the equivalent resistance of the circuit will be more, 1920. So the total current drawn will be less. Okay, the total current drawn will be I equals to V by R equivalent. So here V will be V is 240. Instead of dividing it by 1960, if the one bulb is connected, here we have to divide it by 960 plus 960, that is 1920. So my current drawn will be 240 by 1920, it is 0.125 ampere. So a bulb, then each bulb will get 0.125 ampere. Okay, so the current passing through the bulb will be less, so heat energy produced will also be less, so each bulb appears less bright, because we know that H is directly proportional to I square, Joule's law. So current less, I less, so H will also be less, so brightness will be less. Okay, next.